Hi there. In this video, I'm going to tell you about Snowflake Dynamic Tables. This video, in fact, is one of the modules part of my Snowflake training course, Mastering Snowflake Fundamentals, Insights and Best Practices. In this video, we'll describe what problems dynamic tables will solve, how dynamic tables perform change data capture and the meaning of target lag, the refresh modes, incremental and full, and how to visualize your ETL pipeline. So here we go. So I'd like to talk about dynamic tables, a relatively new feature in Snowflake for producing data pipelines. Let's talk about the challenge that you have when you build a data pipeline. What you're really talking about here is the transformation area, where you're taking data files in from the staging area or landing area, and then you're cleaning and combining them and aggregating them ready for delivery to the end users for reporting and analysis. The thing about these pipelines can get really, really complex. You've got a problem of orchestration, which really means coordinating everything that's going on inside that pipeline. So, for example, you've got to schedule the execution of all of the steps, manage dependencies, make sure everything's executed in the right sequence, and that failures are handled correctly. You need to coordinate the frequency with which each of the steps are actually updated. So, for example, you could have varying pipelines. You can have a sales pipeline that is updated hourly and a finance hourly, but then an aggregate for a daily report that's only done once a day. And you need to make sure the data is consistent at each of these points. And it can be quite expensive to run. For example, if you had a system where you were loading every minute and then delivering the data every minute 24/7, it could get really expensive because you'll keep virtual warehouses running 24/7. I call this Munich syndrome after I visited a customer based in Munich, and they'd come to me to say that Snowflake was very expensive. It turned out what they were doing is running several systems 24/7. They had their production system, a test system, and a system test system, and they were all running 24/7 in order to deliver data to users, but people didn't need them 24/7. There was nobody there at 4 o'clock in the morning, so they could have suspended these. So you need to keep a count of the frequency with which you need the data refreshed. And you've got the challenge of change data capture, which, let's say you've got a couple of options. You've got incremental changes, so maybe you've got one or two changes coming in, whereas from one of your other feeds you've got an entirely new set of data each time, and you need to do a full refresh to process that data each time. But then, having brought the data together, the next step is incremental changes. And you've got a couple of options to do this. You could do hand-coded change data capture, say using a last updated time, or you could use Snowflake streams. You've got a couple of options available to you. And as we've seen with Snowflake streams, it can get quite challenging sometimes. You get an awful lot of steps in the process. You also have the challenge of visualizing dependencies, which can be quite complex. And it's not just visualizing those complexities, but also managing the complexity. And of course, over time, your pipeline will change, and you need to handle those changes and make sure they're deployed correctly and the pipeline still works correctly. So, as I said, you've got a couple of options in order to deliver this. One of them is streams and tasks. Let's see how that works out with a relatively simple pipeline. Let's see the challenge. Let's say we've got data from two tables, sales and stores, and they're both got to be cleaned and transformed into these tables. Then they've got to be aggregated and combined, ready for reporting. Well, if you wanted to do this with streams and tasks, it would look like this. you'd need streams to detect changes, a task to coordinate the ETL execution, and then further streams and tasks to process that data and deliver it for reporting. However, one of the options you now have is dynamic tables, and that greatly simplifies the process to look like this. That instead of having standard tables, you now have dynamic tables with the SQL statement buried in them. And we'll see what that looks like in just a moment. So dynamic tables do simplify the entire process. And the design around dynamic tables is simplicity first. In each of these dynamic tables is a sequence statement that's going to define how that table is maintained. They automatically handle the dependencies. So if this data is changed, this data won't apply until all of its dependencies are consistent with each other. Its automatic scheduling is built in, and it'll also do incremental processing. So you have the choice of, if there's only one row changed in the sales, it'll only be one row that gets processed into here, and then likewise. So how do I create a dynamic table? Well, it's really quite simple. You do create dynamic table, give it a name, and then there are three main parameters you need. A target lag, which says when it needs to be refreshed, what warehouse to run on, and the refresh mode. In this case, we've used incremental. And then the select statement. So this is the query that defines what columns are going to be in here, what data types, and also what data. And this can be almost any select statement at all, including joins and group bys. So the outcome is that your table and query are all in one place. Your results are materialized. Automatic refresh and automatic scheduling is all handled for you, and because the data is materialized, you get fast query results. So let's look in detail at a couple of the particular items. The target lag, which is used to determine when to refresh the data. The target lag, in this case we've got 30 minutes, is the delay between changes in the root source and this table are refreshed. That's important to remember, and so we'll cover that in detail. So let's say we've got changes are applied. Well, this is your root source, the sales table, and in here we've got two dynamic tables in a pipeline, one updated hourly, one refreshed daily. You have changes coming in to your sales table, then every hour those are going to be refreshed in the first dynamic table, and then every day they're going to be refreshed in this table. But keep in mind that's always based upon the time since the root changed. Another point I want to talk about is the downstream lag. And the target lag, let's say we've got an existing lag of the sales of hourly and the stores daily, and then the combined result, the aggregate, is every hour. So every hour any new changes are going to come in, are going to be refreshed in here. Because there's a dependency, this will start after this one has complete, and it will pick up the latest entries from the stores table, but they'll only be refreshed every day. Let's say because we only deliver stores changes every day. Well, let's say we actually change the target lag of the aggregate table and say, actually, I want this to be updated every 5 minutes. Well, now this will be updated every 5 minutes. There'll be nothing to do because these changes are only going to be taken in once every hour, and these once every day. Let's say you want consistent results and you want the lag to be determined by this, because in here we've got a relatively simple dependencies, but we can have quite complex sets of dependencies, complex pipelines of data coming through. One way to do this is to actually define the dependent tables as downstream. And what that does is the lag on these tables is dependent upon the downstream tables. So let's look at what that actually means. Let's say I've now got this set every 5 minutes, then these will be refreshed in time to get this updated every 5 minutes. So every 5 minutes, this will be updated based on its source, as will this one, and then those changes will be applied to here. And one of the features in here is that if there are no changes in the source table every 5 minutes, there'll be no changes applied. So this could be down to every minute, and every minute it will try and keep it up to date. But let's say changes happen to this every 10 minutes or so, or sometimes every minute. It'll always be updated every minute with the latest changes. This won't be refreshed if there's no changes in the sales table. So it's not going to be charging you for this processing. The refresh mode, the options are incremental and full. Actually, there is another option in here, and that's auto, but you've got to be careful, because all that actually says is it checks whether the query could be incremental and then sets it to incremental. If it can't, it sets it to full. It's not dynamically going to choose between the two at runtime. But let's say the refresh mode is incremental. Let's say this pipeline's been running for a few days. You've got 100 million rows in your dynamic table that's been used for reporting, and you've got 100 million rows in your source table, the sales table. If only one row is changed because the type is incremental, only one row will be processed into here, which is great if you have tables with few incremental changes. However, let's say we have fewer rows, let's say 10,000 rows, and instead of it being transactional data, it's now customer data. But every day, let's say, for example, we deliver a new set of data for all of the customers, a refresh mode of full, if this gets rebuilt, it's also going to rebuild this table, which is effectively, it's generating an insert overwrite and then bringing in all of the data and applying the business rules in a single step. You've got to be careful with the full, however, because a refresh, even if you've only got one changed row, it's still going to process the entire table. So you need to decide, do you want your changes refreshed in full every time or incremental? And it really depends upon how many rows, or more likely how many micro partitions in your source table have changed. We also have the problem of visualizing the pipelines, because these can really get very complex indeed. And in Snowflake, you can actually view that quite nicely. If from the main menu, you select monitoring and then dynamic tables, you can see all the dynamic tables you have in the current schema, the state, and the current lag when they were last refreshed. You can also visualize the dependencies and also see the state visually, so you can see that what you have is a sales aggregate based upon sales and stores, and these are all dynamic tables that are reading from these two source tables. So I've now got a hands-on lab so you can get to try out dynamic tables, and I'll see you in the next module. As I said, this module is just one small part of an entire Snowflake training course by Analytics Today, and covers a huge range of subjects. I'm happy to deliver this either as a pre-recorded self-paced training course or a live instructor over 3 days. If you or your company are interested in some of the best Snowflake training available from a qualified certified solution architect, you need to visit my website www.analyticstoday. Let's talk soon.